Finding F inverse has 4 steps. Step 1. To find F inverse. Step 1. Replace f of x with y. Can I do that? Yes, they are the same. F of x and the y values, same thing. So y equals 2x minus 4. In step 2, interchange x and y. And you can say, stop, stop, stop. Why are you doing this? And here's my explanation. This is x for f of x. This is y for f of x. Now, this is x for f inverse, and this is y for f inverse. That's why I'm interchanging x and y. Okay, meaning instead of y, I write x. Instead of x, I write y. That's step 2. In step 3, I solve for y. Can anyone tell us how to solve for y? What will be the first step towards solving for y?
Add 4 to
Of
both sides.
Of course. So I have 2y equals x plus 4. Excellent. And then?
Divide by 2.
Excellent. 1/2 x plus 2. 1/2 x plus 2. Now, in final step, rename. Replace y with f inverse. So f inverse of x is 1/2 x plus 2. This is it. This is the 4-step procedure. Once I know that a function is 1-to-1, I can determine its inverse. First step, I replace f of x with y. I can do that because they are the same. In step number 2, I interchange x with y because this will be the new function that I'm looking for. Then I solve for y. Once I have done that, all I have to do in the last step is very simple. Just replace y by the notation f inverse. And this is it. What I would like to do now is graph both functions. Graph, that's not good anymore. Graph both f of x, which was 2x minus 4, and f inverse that we just determined, 1/2 x plus 2, on the same coordinate system. Okay, here's the coordinate system. And we start with f of x equals 2x plus 4. 2x minus 4, of course. Can anyone remind us how to find the x and y intercepts for a line or for any function? How do we find the x and y intercepts? Anyone remembers? How do we find the x and y intercepts?
Set it to 0.
Yes, what am I setting first? Yes.
2x minus 4 equals 0.
So in other words, you're saying y equals 0. Perfect. Okay, 2x minus 4 equals 0. How much is x? Perfect.
2.
Yes, x equals 2. So what is the ordered pair I have to plot?
2 comma 0.
Excellent. Indeed, so x equals 2. So we plot 2 comma 0. Okay, I'm going to use, I don't know, these colors may not be good anymore. So this is 2 comma 0. Good. This is the x-intercept. How do I find the y-intercept?
You plug in 0 to x.
Excellent. So when x equals 0, how much is y?
-4.
Indeed. So 0 comma -4. Perfect. Excellent. So 0 comma -4. 1, 2, 3, 4. I'm ready to graph this line. Very good. Excellent. Thank you very much. And this is f of x. The next step, before I graph the inverse, please remember, every time we are asked to graph the function and its inverse on the same coordinate system, we have to draw the line y equals x, which you remember is the line that bisects the first and the third quadrants. We have to draw that line. It's a dotted line, it's not part of the graph, but it has to be there. Okay. Now, you perfectly gave me 2 comma 0 and 0 comma -4 as ordered pairs for the function. When you look at these two, can you come up with the 2 ordered pairs we need for the graph of the inverse function? Without any... Yes, go ahead.
0, 2.
Of course. 4, 0. Exactly. So 0, 2 has to be exactly opposite over this line. It has to be a mirror image. It has to be a mirror image with respect to y equals x. So all you did have, or you had to do, was just reverse this and reverse this. So this has to be a mirror image. 1, 2, 3, 4. My graph cannot be perfect, but you understand that this is the reverse. 0, -4 changes into 4, -4, 0, and 2 comma 0 changes into 0 comma 2. Where the function, the f of x, crosses this line, the inverse has to cross. How come? Because this point has the same coordinates, 5, 5, 10, 10, 3, 3. If it's part of this, it has to be part of the other one. So that's why I always graph the function. I graph y equals x. I identify where it may not cross. Maybe it does this. But if it crosses, if one of them crosses this line, the other one has to cross it at the same point. And now I'm ready to graph. Notice that no calculations were needed for f inverse whatsoever. F inverse of x. This has to be an absolute mirror image. So if I were to fold the graph on y equals x, the two functions have to overlap because they are mirror images with respect to y equals x. So that's how we graph the function and its inverse on the same coordinate system. Now, one more comment here before we look at more problems. Here's my comment. Let's create two very simple functions that are inverses of each other. So I create f of x. Let's say 2x. Multiplication by 2. What do you think, without any calculations, what do you think the inverse function will be? Your wild guess.
Around half.
Indeed. the inverse operation, not the opposite. So you said it correctly. You determined the inverse operation. Perfect. So now, final question. If I determine f, the function composition, f inverse, and if I determine f inverse comp f of these two functions, what do you think the result would be? Let me help you. So I have this number. I multiply it by 2 and then immediately divide it by 2. Or I have this number in the other sequence. I divide it by 2 and then I multiply it by 2. What will the result be? In other words, I'm giving you $2, you put it in your pocket, and then 3 minutes later I'm saying, although it's not multiplication, but I'm creating another example. I'm giving you $2, and then 3 minutes later I say, give my $2 back. What has changed in your pocket? I'm giving it to, and I'm taking it away. In other words, if I multiply by 2 and then immediately divide by 2, or I divide by 2 and then immediately multiply by 2, what will be the answer?
Zero.
You mean no change, not 0. Multiplication by 2 and division by 2 will not give us 0. It means no change. No change, none whatsoever. Now, if I multiply by 2 and then divide by 3, that's a different story. But if I multiply by 2 and then divide by 2, nothing happened to x. If I divide by 2 and then multiply by 2, nothing happened to x. Why? Because these functions are inverses of each other. You will never get x if they are not inverses of each other. So what I'm saying is, if I'm given a function f of x and I'm given a function g of x, if this happens, what can you conclude about f and g? Very important rule. So if we're given f and if we are given g, and we create a function composition in both directions, and the answer is plain x, not 1x, not 1/2 x, not x squared, not x cubed, just plain x. What do you conclude about these two functions? If both situations give us x, what do you conclude about f and g? For sure, they are what are they? F and G, inverses of each other. F and G are inverses of each other. What does it mean? Like these two. They are inverses of each other. That's why the answer is x in both cases. So if I'm given two functions and the function composition in both directions is x, I will conclude for sure these must be inverses of each other. There is no other way. If the answer is x squared, they're not inverses of each other. If the answer is x plus 3, they're not inverses of each other. But if the answer is plain x, they are inverses of each other. So let's look at an example in which we are asked, are these two functions inverses of each other? Yes or no? I'm looking to find an example. Okay, here it is. Problem 4. on page 323. F of x is 4x plus 9, and g of x is equals x minus 9 over 4. The question is, are they inverses of each other? Are f and g inverses of each other? I'm not asked to find the inverse of either one. I'm asked, are these inverses of each other? What do I have to determine to establish whether they are or whether they're not inverses of each other? What should I find? What should I calculate? What will you calculate? What do you think? It's okay if you're wrong. What do we need to calculate in order to establish whether they are or they're not inverses of each other? What do you think?
F of G.
Exactly. And
G of F.
that's it. Excellent. Perfect. Let's just do that. That's all we need to do. So 14. Good. So f comp g of x. Slowly, I write the formula first, or the definition. F of g of x. F of g of x. I replace g of x by this. F of x minus 9 over 4. Now I look at f. What does f tell me? F says this. F of blah equals 4 times blah plus 9. And this is my blah now. So 4 times that plus 9. I need to simplify this. How will you simplify it? What will you do first? Yes or no? Would you simplify? Can you?
Multiply by 4.
You mean simplify. Divide the denominator by 4 and divide by numerator by 4. So this is x minus 9 plus 9. What is the final answer?
X.
That's it.
X.
That's it. Awesome. Let's find g comma f now. Do you think that if f comma g is x, will g comma f be x? Wild guess. The answer is of course. Of course. Good. So g comma f. The definition, g of f of x. I replace f of x by 4x plus 9. G of 4x plus 9. Now I carefully look at g. What does g say? G says g of blah equals blah minus 9, everything over 4. This is my blah now. So blah plus 9, blah minus 9 over 4. How will you simplify this first?
Cancel all the fours.
You have to combine like terms first.
Okay.
You cannot simplify in a sum. We only simplify factors. We write this, and the answer is
X.
perfect. Exactly what we expected. What do you conclude in view of this? What do you conclude about f and g?
They're inverses of each other.
Indeed. In other words, f inverse of x is g, and vice versa. So this is x minus 9 over 4. Okay, so I'll say f and g, based on what we saw, f and g are inverses of each other. This only happens if f comma g is x and g comma f is x. Only then functions are inverses of each other. Any questions on inverse functions? I'd like to look at a word problem. Any questions on the inverse function? Okay, let's take a look. And this is on 325. 325. The graph represents the probability. So the y-axis represents the probability of two people in the same room sharing a birthday as a function of the number of people, the function of the number of people. Call this function f, fine. Explain why f has an inverse that is a function. In other words, does this function have an inverse function and why? Which functions have inverse functions? Which functions have inverse functions?